Welcome back to part 2 of our video series. In this part, we want to talk about data types, operators, and variables. Let's start out with data types. Well, to program and to make operations with certain things, we need to first of all understand which things we can make operations with, right? Can we write text? Can we make additions with numbers and stuff like that? For that, a programming language needs to make sure which data types it accepts. For Python, these data types are strings, str, for text. A string is basically a set of symbols which I can display in a row, which in the end then represent text. Like hello world could be a string. Then we have integers. So integers, as the name says, so natural numbers, whole numbers, no decimal points. Just for example, 1, 2, 3, those are integers. Then we have floats for decimal numbers. We call it float based on floating point because in a decimal number, I'm just writing text for a second so I can better display that. Right here, I'm later on deleting that again. So because it's a floating point, it could be 1.2567, but it could be as well, the point can float in between. It could be 12.567. So the decimal point can float in its position from left to right. That's why we call it floating point for a decimal number. So we have floats representing then decimal numbers. Then we have lists, often called arrays, which is then an array, a sequence of lists of different types. So in a sequence, in the list, in an array, we can display then several things like the first item, the second item, the third item, the fourth, the fifth, the sixth item, which can be then any data type which is available. So we can only have a list of numbers, of integers or floating points, or we can mix it up that we have a string, a floating point, an integer, and so forth in that array, in that list. A Boolean is another data type, which is basically the smallest amount of information we can basically display in a programming language. It's a state of 2. It's either true or it's either false. That's a Boolean value. It only has 2 values, true or false. Then we have dictionaries, but we don't use that so often, so mainly you can ignore it. But in a dictionary, we can put in a list of items, so to say. We could basically say the first entrance of a list of a dictionary is then given by a name John and age, and he's 36 years old, so his age is 36. So what we could do is basically have items. So I can describe a person by its name, by its age, by what the person studies, for example, and I could display that in such a dictionary that the item consists of these values, this set of values, and is then one item of that dictionary. But for what we do today, we don't need that. However, data types are only useful so much if I cannot do anything with them, so we use operators as well. Operators enable us then to manipulate, make operations with those data types. For example, with a plus symbol, we can add numbers or we can subtract numbers. However, that doesn't only apply for numbers, for integers or floating points. It does apply for text as well. So strings we can add together. So we have the first string and the second string. We add a plus symbol in between, and then we have a larger string consisting of the first part and the second part in a row concatenated together, for example. We have a multiply, so we can do multiplications, we can divisions, we can make special integer divisions, which only gives us full numbers. So 3 with an integer division 5 gives us 0 because we don't have a floating point. We only use the first part, so the integer here. And we can make modulo operations, which are quite often needed. What is a modulo operation? Well, it gives us the rest of a division. So, for example, if I divide 5 by 2, it has a rest of 1. Why? Because 2 fits 2 times in 5. Then we have 4. 2 times 2 is 4. So we're left, the rest is 1, which we cannot divide by the integer 2. So basically, it gives us what is left after a division. This helps us. So, for example, if we want to know if a number is odd or even, we can divide a number by 2. And if we have a rest of 0, it's even, because it is able to, we are able to divide it by 2 without having a rest. The rest is 0. And if the rest is 1, it's an odd number, because if we divide it by 2, there's always 1 left if it's odd. But we can do that for written division, for example. That would always be the rest. So if we divide 7 by 5, it would be rest of 2. Then we would make 2 plus and add a 0. So we have 20. Then divided by, what did I do? 5. Rest 0. So it's then 1.4. Yeah. You get the idea. Then we use that symbol for making an exponent, so exponentation. So the exponent of 2x to the power of 3 would be 8, because it's then 2 times 2 times 2, 3 times 2 multiplicated. That's basically what we can do by that symbol. Then we have comparison operators. We can look if one is smaller or larger than the other one, so smaller or larger. So 3 smaller 2 would be false, but 2 smaller 3 would be true. And the other way around, 3 larger 2 would be true, because that's a true statement, while 2 isn't larger than 3, so that would be a false statement. So a comparison operator gives us either a true or false value. We then later on can use that in if-else statements. So if 3 is larger than 2, then do, because true, and false, do not, whatever follows in the code. We can do that with smaller and equals, or larger and equals, or exactly equals, or not equals. So it's different from as well. We can then make combinations of two of such logical operators. We can say if the left part and the right part is true, then it's an AND statement. Or we can say if either the left or the right part is true, that's an OR statement. Oh, sorry, again. That happens if I double click that. So, and not, it just makes a difference. If it's false, it makes true, and if it's true, it makes false. So these are the more challenging ones, I guess. So it basically says we have a left part of a statement and a right part of a statement. For example, 4 smaller 5 and 4 smaller 10. If the left part is true and the right part is true, it's true. However, if this would be false and this would be true, it would be false. Or if this would be true and that would be false, it would be false. Or if that false and that false, it would be false. So only in the case that both sides of the statement between an AND are true, it will be true. While in an OR statement, it's enough if one of the two is true. So if this is true or that is true, that is true. 4 is not smaller than 2, but 4 is smaller than 5, so the result is still true. But if now here's 7 is smaller than 5 and 4 is smaller than 2, then it would be false, because both sides are false. And not just makes the difference. The opposite, sorry. The opposite, not the difference of the statement. So if it's false, it will be true, and the other way around. So variables. Okay, now we do know which data types we can make operations with and what operations, but how do we make those operations? So we need variables. It's the most basic element of a programming language, and we basically do the following. We have a variable, which we can name whatever we want to name it, and in that variable we can store a certain data type, and it holds then that certain value for a given time. For example, we could call our variable slice of cheese, or we could call our variable Professor Straub is awesome, or we could call that variable just A, X, Y, or I don't know, my variable. So let's start off with a comment so we do remember what we do. We want to assign values to a variable. And how do we call the variable? Let's just call it my variable. So so it's always a good idea to call the variables in a way that it's logical and makes sense, so you do know what it stands for and it's easy to read for you. So calling it slice of cheese is probably not the best idea if you don't want to represent a slice of cheese. So now we can store a value in that. We could make it a string, so we could write text. We could make it a floating point, or we can just make it an integer if we assign a whole number, an integer to it, like 42. And we can check if it actually works. If we then print that variable, it should now print 42 because 42 will be stored. So we will run that code. So 42 is then stored in my variable. And then if we print my variable, 42 should then be printed. And 42 is printed. And to show you just that we can store different values in that, not only integers, we make a second variable, my second variable. And in that we now store 42 as a text. And now we can print that as well. Exactly. Now we get auto completion. I'm just using that. And now 42 should be first that, and then that should be printed, and now the text is printed. So you can see that one is printed as well as a text. However, we can only store and print data. We can perform various tasks with variables like additions, subtractions, multiplications, all the things we have here in our operator options. So let's just try some of them out. Let's just say we want to add to a certain variable a certain amount. So first of all, we need a new variable which we can use. So let's say we now need a variable with a certain value, Let's say we call that variable some number, and because we want to store some number in it, and let's store 13 in it, let's say. And now we want to change that. We want to add a number to that variable. So we add any number to some number. No, it's probably better if I write that variable correctly, so I better can remember what I did. So we want to add some number to it. So we want to basically say some number plus 4 or 1 or 2, or let's say we add my variable, so our 42 up top here, because we already have that stored. This we now have available because we have executed that code. If we don't execute that code before that, we don't have that down here. Because during the runtime, so if we close it now and open it later on, it's a new runtime. Throughout one runtime, it only remembers the things, the variables, the executions you already have executed in that runtime. So right now I have my variable because this one is executed. If I never executed that one, I wouldn't have my variable here. But now I have it. So now I have my variable available, and we add that to that. However, it's not stored somewhere new, so I need to store it somewhere. So let's say I want to store that in my result. Let's store it in my result 1. So this is a new variable in which I store the result of this addition. And to see that it worked, I want to print my results 1. All right. 55. 13 plus 42 is 55. That's correct. Cool. And what we can do more, we can also perform further calculations. For example, we can do plus, we can do subtractions, we can do divisions, etc. Right? And And we usually have, yeah, etc. All right. So let's just show you that. Let's say we print something. We want to make 4 plus 2 and then divide the result by 2. However, if we would do division in the order of operations, it would execute 2 divided by 2 and then plus 4. So to make sure that 4 plus 2, if I want to have that calculated in the first place, I need brackets to make sure the order of operations, first the addition and then the division by 2 here. And that should then be 3. Exactly. If I wouldn't do that, it's probably 5. Because 1 plus 4. Yeah. Order of execution is important in programming languages as well. All right, now let's go to your first 2 exercises in which you should hit pause. I show the solution in the next video. First exercise, calculate the number of seconds in a year, store it in a variable, and print out how many seconds there are in 3 years. So you do think about how many seconds are within a year. You can do that by using seconds within a minute, minutes within an hour, and so forth. Store it within a variable, and then give me the results of 3 years. Second order of exercises or things you should do then is calculate the remainder of 5 divided by 2 and update it. So how much is left, how much remains, how much big is the remainder if you divide 5 by 2 and print that here. Hit pause, do the executions. I will show the solution in the next video. Thanks.